English to maths. You gotta be kidding, man. Alright. How are we going for sound here, guys? It's a bit quiet, isn't it? That's alright, we'll get started. Let me just get rid of a few things. Alright, hey guys, welcome back. This is what we're doing. I haven't seen you guys in a couple of, I think almost 6 or 7 weeks since MCAT, especially for the level 1s. But as promised, we've got, I think, TEG today. And I'll try and do another one sometime this weekend. Now, before I get started, just a couple of things. The first thing is that if you are around, I just want to double check, is this actually going or not? Let me just double check, give me a second. Switch account. Oh, yep, we're kicking away. Yeah, so just to kind of get things started, this weekend from 2:15 to about 3:45, I've booked out a room at Munriwa Library, so I'm gonna hang out there for about an hour and a half. You know, if anyone needs help, you're more than welcome to come and join. I think it's like a room for about 36 people. Either if no one comes, it's not a big deal. I've got my work to do, so I'm just gonna chip away. Now, in terms of some people have asked, is it for level 1, 2, or 3? It's basically whoever's in the area can come through, guys. So that's happening this week, Saturday, between yeah, man, I'm not very far from it. So yeah, this is happening this Saturday between 2:15 and 3:45. All right, look, so we're gonna get started with TEG because we are gonna cover today. We're just gonna focus mainly on linear. And if we do have time, then we'll see how we go. Like I'm looking at mainly skills, guys. So if you are comfortable with like drawing straight line graphs and things like that, then this tutorial is probably not for you. But I'll try and do an exponential and a quadratic session as well. And I'll try and do like a quick crash course in geometric reasoning. Lohita, I'm really sorry. I think I messaged you earlier. Like I don't do chance and data, and I don't have enough time actually to kind of like do everything here. Okay, so let's kind of have a look at we're gonna have a look at when would the quadratic exponential session be. We'll see how long it takes to do the linear one today. I don't think the linear one takes that long, and the exponential one is actually quite handy to do, and I don't know how your teachers have been teaching it. The way that I could actually work is basically like, you know, how do I say it? We'll see how long it takes to do linear, and then we'll figure out exponential. Danica, speaking about botany, this whole idea came after I visited the botany library on Saturday last week. I saw like a whole bunch of kids sitting there doing maths on Saturday, and I was like, I kind of felt a bit, what do you call it? I didn't want to go just kind of snooping because they were all working inside that little room. So I was like, I just kind of peeked in, and I was like, maybe this is not a bad idea. I could hire out a room. So I tried to book botany library, but it was all booked out. So unfortunately, I couldn't do botany. Josh, I wish I could tell you. All I do is I basically have just been using questions from past exam papers and so on. Well, look, we're going to try and see if we can try and hit exponential today or not. But I probably will do spend like a full session on quadratic. Maybe we'll do a linear for like 25 minutes, and then we'll do exponential. No worries there, Gabriella. All right, so we're going to get started with straight line equations. Now, I have been kind of having a look at the last kind of few papers that, let me just open up these papers. It's been really weird because like some of the questions have been they've been starting. I mean, if you look at desktop camera there we go. So this is the last 2 years worth of papers, right? Like if you look at the last 2 years worth of papers, they've basically started off with pretty much a straightforward equation of a straight line. That's 2021, that's 2020, and I can't remember if they did that in 2019 as well. Let me just have a quick look. Yeah, 2019 as well. All right, so looks like it's been kind of like a standard starting point for these questions. So we'll actually kick off with a straight line equation, and then and then we can actually go from there. All right, now what we're going to do is, I know some people don't have a graphics calculator, so we're going to actually work through some, just showing you guys how to do it without a graphics calculator, and I'll show you guys how to do it with the graphics calculator as well. Yeah, so let's get started. Now with any kind of so what we're doing straight lines at the moment, and this is going to be pretty much like a survivor's guide light, right? So we're just doing like really basic stuff that we can kind of be confident about. So let's say we have something like we have a straight line that goes through like that. I guess the first thing you really want to be doing is, regardless of whether you're using a graphics calculator or whether you're using just using a manual method, I would actually say that you have to find like 2 clear points. All right, and what do I mean by 2 clear points? Let me go back to this example here in the exam. So if you look at, I don't know, I'm not going to work on this one, I'm going to give you another example. But like in this example right here, what's really important is that you actually pick a point that you are absolutely sure about. All right, so what we don't want to be doing is picking -1 as an x coordinate here, because this value here, it's somewhere in the middle. Now we're not sure what that point is, so you don't really want to be picking something like that. So if you go along, okay, at 0, -3, now that's a very good point to be starting with. And then if you go along, let's go at 1, you're looking at like maybe 6.5. We don't know that. All right, so we want to make sure we actually pick a point where the line is actually going through the coordinate, like the x part of your axes, right? So if you look at it, you've got 2, -10, you've got -2, +4. So you've got like a few selection of points here. So coming back to my example here, I am just going to kind of throw some points for you guys, and we're going to kind of work through this. Okay, so we're going to have -1 and 5, and let's say we go with something like this, which is going to be 3 and I don't know, I'm going to throw some numbers here, like maybe go -3 actually. No, let's make it -1. All right, so we got these 2 points here. Now, like I told you guys, I'm going to show you guys how to do it by graphics calculator, and I'm going to show you guys how to do it manually as well. But what I might do is I'm just going to give you guys like maybe a minute just to have a go at this. What's the time? 7:45. So 7:46, I'll actually go through the answer. It doesn't matter which way you do it, whether you do it by graphics calculator or manually. Just have a go, and then I'll try and get to some of the comments, and then I'll go through the answer, both methods. All right. Yeah, Carol, so it was, like I said, you know, the botany library one is where the idea started, but I don't think I can book that room out, because I checked out on Saturdays and the room is like, I mean, like, look, if like, I don't know if it's being used for a purpose or like people just study there, but I guess maybe what I should do is like just wear an Infinity +1 t-shirt and just walk around and say, is anybody looking for help, like how you do in a classroom? Yeah, Josh, there's a lot of old exams, but speaking about that, Jacob, I would almost say like you can ask your teachers for some old papers, but like especially do the practice papers that they gave you in school, like for the exams, like a mock exams. It's really good idea to kind of like, especially for TEG, sticking to like the last 3 to 4 years, because the paper just keeps changing all the time. I'm good, Lila. Yeah, I'm good. All right, so let's do this question. All right, so now you guys would have actually been taught this so many different ways to do this manually. All right, now I chose like a particular one which is quite handy to use, because if you are carrying on with maths at level 2 and level 3, it is definitely worth knowing, and that's like equation of a line. But also I also use the gradient formula as well, which is really good as well. But some people like to do this, they go, change in y over change in x, and then try and work it out like that. Now let's do that one, because that's like, as I said, this is a survivor's guide, so I'm not going to complicate things for you. All right, so what we have is we're going to write the equation of the line. Now we're going to write down y is equal to mx plus c. Now usually what we can do is if the graph is really nice, we can actually pick out the c value, which happens to be wherever the graph actually cuts the y-axis. All right, that's what the y-intercept is. Now when it comes to m is what we call the gradient, so that's literally the slope. Now one quick little tip for you guys is this: if you do have a straight line that's actually going, now this is always going to be confusing, because like I'm trying to do this, is that going down? And yeah, I think it's going down on you guys. Yep. Okay, yeah. So if the graph is actually going down like this, then what happens is it's actually negative, right? Because it's actually going bottom. Is that right? Like, it's always reflective here, the image. So yeah, so that's going to be a negative graph, and as for a positive graph, it's actually looking like this, so the graph is actually going up. So a good idea is that if you look at your straight line graph, and if it's pointing down, your gradient has to be negative. Now what we do is something called, with gradients, we're going to have change in y over change in x. That's something that's always useful to remember. All right, so we're going to put down y is equal to change in y over change in x. Now there is a formula for it. If you remember the formula, great. If you don't remember the formula, just write it down like this. All right, this is really easy. Change in y divided by change in x. Okay, write it down like that. Like the formula, if you like using the formula is going to be like this: y2 minus y1 divided by x2 minus x1. It doesn't matter which one you use. All right, all they care about is how you actually get to the gradient. So we're going to look at change in y. Now change in y, so if I look at the y value, so I'm looking at the y value here, which happens to be 5 and negative 1. Yep, we can, Gabs, we can actually do rise over run as well. That's another one you could do. Like I said, there's so many different variations that you can do, right? So I'm actually going to do change in y. So 5 is changing into negative 1. But what I do is like I go negative 1 minus 5 divided by, the next part is I look at change in x, which happens to be 3 take away negative 1. Now, one thing to notice is that this point here is actually here like this. So you don't want to mix the order of those points. So if you take the y value for the second point, then right below it should be the x value of the second point as well. So look at it, this is the first point there. Now I've actually put that on the other side. Oh, sorry. And that's where the coordinates are for that. So 5 and negative 1. Now let's actually do this on your normal calculator if you have it. Negative 1 minus 5 is minus 6. And then 3 take away 1 is just positive 4. So we're going to get negative 1.5 as your gradient. What about the triangle for easy point strategy? Triangle. Daniel, I'm not sure what the triangle one is. Are you talking about delta y, delta x? Sometimes they do that. Anyway, we've got the gradient here. Now comes the easy part of substituting. So we've got y is equal to negative 1.5x plus c. Now at this point you can pick any one of these points. So you can pick out negative 1, 5, or you can pick out 3, negative 1. I'm going to pick out 3, negative 1 in this case. And what I'm going to do is I'm going to substitute it in this equation. So wherever I have x, I'm going to replace it with 3. And wherever I have negative 1, I'm going to replace it with y. So what I've got here is negative 1 equals negative 1.5 multiplied by 3 plus c. So I'm going to get negative 1 equals negative 4.5 plus c, and c is equal to positive 4.5 minus 1. So I'm going to get c is equal to 3.5. So the equation of this straight line is going to be negative 1.5x plus 3.5. Yep. Like look, you can actually find rise over run. That should work as well. Yeah, like I said, there's just so many ways in which you can actually do this particular question, right? So there's a lot of strategies for you guys. Now, if you are using the graphics calculator, if you are using a graphics calculator, there is what has she got? Google. There is a video on one of my playlists of how to actually do this. All right, I think it's. Let me just find it. So if you go into my channel, the main page, right at the bottom there's graphics calculator skills. Click on the playlist, and I think form a linear equation given 2 points. Basically, if you have a graphics calculator, I would recommend 1, 2, 3, 4, 5, all 5 of these videos there, and you should be pretty confident with that, especially if you're doing TEG and you're taking a graphics calculator inside the exam. But anyway, as for us, we're going to kind of have a crack through this. So we've got menu, we're going to go into stat mode, and we're going to put our 2 coordinates there. So we've got -1. So you actually put all the x values here and then put all the y values here. So we've got -1 and 5. And because I'm lazy, I'm going to put -1 first here. And I've got 3 here. So at this point, I've actually put both of my points. I click on calc, 1 variable. No, that's not it. Not calc, sorry. I was thinking something else. Graph 1. And there you go. You can see my 2 points right there. And then we're going to go calc. And we're going to choose this middle one here, which is single variable, which is x. So it's going to do it as a straight line. And as you can see, it actually has a and b. Now, if you look at down here, it actually has y equals ax plus b. Now, I don't know why. The graphics calculator could have been a bit more helpful by putting this as y equals mx plus c, but they've decided to use ax plus b. So it doesn't matter. The a value is the same as the m value, which is -1.5. So that's the gradient. And this b value is the y-intercept, which happens to be 3.5. So with these kind of straight line questions, you do not need to show any working. You can actually go straight to the graphics calculator, put that in there straight away, and within like 30 seconds, you actually have an answer, which means you don't really waste a lot of time with this question. So so basically that's what it is. What I'll do is I'll ask you guys if you have any questions. If you are comfortable with it, then we will do one example, and then I'm going to show you guys some examples of merit and excellence. Not excellence as much, but merit questions that they could ask when they talk about vertical shift and horizontal shift. All right. So if you're comfortable with this question, then I'm going to put up another. Yeah, I'll actually. Should I give you guys the points? No. Hang on. Let me do this. Give me a second. I'm going to try and see if I can pull this off. I'm going to have to draw the graph and then hide it. So just give me a second with 2x. All right, so what I'm going to do is I'm going to put up a graph for you guys, and let's see if you guys can actually come up with the equation. I'm not going to give you guys the points or anything like that. So let's see if this works. Desktop cam, full cam. No, that's not going to work. I'll just add it here. Give me a second. Desktop capture, Desmos. There we go. So what I'm going to do is I'm just going to put this question up here for you guys. But what we'll do is shrink it like this. There we go. So you can still see the working. Nice. Okay. So I'm going to leave this question up for you guys while you have a go at this. And I'll try and get to some of the chats on the side there. So, I mean, if you guys are good with this, then we're probably going to be done with like everything to do with the linear equation, because there's nothing else to do with the linear equation. After that, we can actually go to exponential. All right, so questions on the chat. Finn Brennan, you've got lot of love from Kati there. Welcome here, Yak. You've finally arrived. Kati, how much of the exam can be done with only your calculator? I would say there's at least like some of the achieved questions, definitely. But it really depends on the day, right? What type of question they ask and how you kind of use your calculator. I know a couple of years back I would have said that majority of the paper could be done apart from the exponential ones, but now it's not so much. Gabs, that is so true. I love that statement. I think your graphics calculator is older than you. In fact, I'm actually using a graphics calculator from 1999, which is still working. Great little machines, 22 years, it's still going and still can be accepted in NCEA level 1 exams. Krish, to find the previous tutorials, if you go into my main channel, under like just, if you just go to my main page, you're going to find like playlists, or even under the main section of my channel, you'll find all of it sussed out. Otherwise, go to my website. I've started kind of organizing everything there. You can find my website on any one of the descriptions here, and you should be good to go there. Yeah, playlist on the YouTube channel. Jackson, thank you so much for the donation, but I've tried getting into Fortnite. I really struggle because I'm a PC gamer, and sometimes it's just like I try to do that on the PlayStation and it was annoying. Yeah, Connor, it is possible. I mean, like, you can definitely do that. So Kathy, for that question that you actually wrote, you can actually do that. That's fine. Like, that'll actually work out fine. Will you do domains? Yeah, we can do some domains in this. It's not too bad. So yeah. All right. So we've got a few answers coming out. That's really good, and I think you guys got majority of it on the money there. So let's have a look at this and just do this quickly and then get it out of the way. All right. No worries, guys. Don't worry about it. You're welcome. I mean, I've just been doing this for a while now, so it's a good bit of fun. All right, so let's actually go through this. Now, I'm going to pick like a couple of points, as I said to you. Looking at here, this point right here looks good, 2, 0. And then I might actually pick like 0, 4, for example. All right. And now, just saying, like in this case, it came out real nice. Now, because in this one, I am very confident with my what do you call it, my y-intercept, because I can actually see the line going through it being -4. What I can actually do is I can do this. I can actually put down straight away that the C value is equal to -4. And then I've got my 2 points, which is 2, 0 and 0, -4. So I'm going to put them as 2, 0 and -4. So the gradient is going to be -4 minus 0, rise over run. So -4 minus 0 over 0 minus 2. Now, it doesn't matter which order you put this in. All right, so you might have actually gone gradient is equal to 0 minus 4, and then 2 minus 0. Guess what? You're going to get 4 over 2. In this case, you're going to get -4 over -2. Both of these things is equal to 2. So it doesn't matter which order you go with. Now, this equation, yeah, it's going to be y is equal to 2x minus 4 is what we are actually looking for. Calculator, graphics calculator wise, I'm going to get rid of this just for a second. So graphics calculator wise, we're going to go put those 2 points in. So we've got 0 and 2, -4 and 0, and we're going to click on graph, calc, x, and there we go. We get 2 and -4. All right, so pretty straightforward there with the straight lines. All right, now comes the next part of the question. I'm gonna try and see if I can find the schedule for this so we can kind of see what you need to do. Right, so this, I don't know how many ones did it come under. Okay, came last year, but it's all right. We can just put this up here. So this is the next part of the question that they sometimes try and ask you, right? Find the equation of the new line if it's translated 20 units up and 10 units to the left. All right. So this is something that they tend to do quite a bit. It's kind of come on and off. Like they always have, like every second year or every year, sometimes they've had it like this question that comes up where they say, what happens if this graph is actually moved up or left or right or down, whatever, right? So what we want to do is we're going to have a look at these graphs, right? What would actually, what would happen if you actually shift them up? Now, I'm going to give you guys a tool or like an idea, and this idea will work not just for straight lines, it'll also work for quadratics, and it'll also work for exponentials. Okay, so this is like kind of like this is something that I say, like, you know, if you understand this and you get a question like this, you're gonna actually walk out with a merit for that question, right? So what you need to know is this: when they say, like, let's say we take this graph 2x minus 4, right? And I'm gonna bring it back. Where is that graph? Okay, so there's 2x minus 4. Let me just open it up a bit so we can see. All right, so we've got 2x minus 4, and what we want to do is, let's say we want to shift this graph up by 3 units. All right, so we want to move this entire graph up by 3 units. So if you look at this, I need to duplicate this. There we go. And I'm going to put this original graph here. I'm going to put that as a dotted line. That was my original graph. And this is my new graph. So let's say I want to move something up or down. Like this graph, we're just going to look at up or down. Okay. If we want to move something up, all we do is plus 3. Like, let's say 3 units up, then we're just going to add 3 to the end of it. If you want to move down by 5 units, we're going to subtract 5 at the end. So basically what we're going to do is this. If you want to move a graph up, so graph up at the end of the equation. So if I say graph up by 3, end of the equation, I'm going to add plus 3. If I want to move the graph down by 5, for example, then at the end of the equation, I'm going to put down -5. Let me know if that kind of idea is actually okay. All right, that's like that actually works with anything. So let's say you have a parabola, like let's say you have a parabola like this, right? So I'm going to put down a parabola. Y is equal to x squared plus 3x minus 2. And I want to move the graph up by 3 units, then what I would do, the new equation is going to be y equals x squared plus 3x minus 2, and I'm just going to add a plus 3 at the end. All right, so this is basically, that's all we have to do for moving up and down. Let's say, what about an exponential? If you have an exponential like this, y is equal to 2x, and you want to move it by 3 units up, then your new equation would be 2 to the power of x plus 3. So that's like one of the key ideas that you guys need to know. When you want to move a graph up or down, all you do is whatever units you want to move up or down by, you just add it right at the end. So let's go back to all of these other graphs that I wanted to talk to you guys about. Like I said, I'm sorry, I'm kind of like drifting between the two. Like we did say we're going to do linear, but this part kind of covers it as well. So I'm going to put this other graph, which was x squared plus 3x minus 2. And what I'm going to do is I'm going to put this as a dotted line. And I want to copy this. So if you look at it, if I want to move the parabola up by 3 units, it's going to get rid of the straight lines for now. So if I want to move it up by 3 units, I just add plus 3 to the end. I'm going to change this as well to line graph so it's a little bit better. There we go. So if you guys have a look at it, oh, you guys can't see it. Sorry. Oops. I actually hit it by mistake and I thought you guys were looking at this the whole time. There we go. That's better. Sorry, guys. Where is it? Let's just get rid of this. So we've got our parabola right now, x squared plus 3x minus 2. I want to shift it up by 3 units. That means all I got to do is I got to do plus 3 at the end. And notice now that this graph is actually moved up by 3 units. Like, look at that. That's negative 4.25. That's now changed to 1.25, negative 1.25. That's actually moved up by 3. Let's say I want to move this parabola down by 5 units. Then all I have to do is just minus 5 at the end of the equation, all right? So yeah, so that's pretty much the idea for like what we call vertical shift. Vertical means going up or down. When you're doing a vertical shift, you are simply taking the value and just adding it up or down. Josh, absolutely, all these videos come the moment I stop streaming at about 5 minutes. It starts converting to a video and you should be able to catch a replay of it straight away. Okay, now we've done vertical shift going up and down, but now we want to do horizontal shift. So a horizontal shift is what happens to the graph if I want to move it left or right. This one is not as tricky because, like, look at this. What we're going to do is we're going to go y equals 2x minus 4, and we want to shift it. I'm going to choose a different number, 4 units to the right and 7 units to the left. I'm just going to put those as 2 examples so we can actually see what happens there. All right, so let's go. Where is that's how I do it. Okay, so we're going to go back to our straight line here. Now, when it comes to moving something to the right, right now I've got this red line here, and I want this red line to move 4 units towards here. All right, I actually want it to go from here, 4 units to the right. Oh no, wait, to the right. Sorry, I'm thinking this way. So right now this is at 2, which means I want to move it 4 units to the right. It's going to be at 6 and 0. Now, what are we changing here? We're not moving anything up or down, right? So we're just going to leave it as it is. But then we're going to go into the x, and wherever there's an x, we're going to replace it with how many ever units you're going to move it across. So this actually will become 2x minus 4. And likewise, if I want to move it 5 units to the left, then I would simply just go x minus x plus 5. So that's actually 5 units. Have I done that right? X plus 5. 1, 2, 3, 4, 5. Yep. That's actually moving it 5 units to the left. So that's the only kind of thing that you need to remember. Like, it's to move when you're doing a horizontal shift, you got to change the number. So wherever there's an x, you've got to change that. But for the vertical shift, you just add the number at the end. Whether it's moving up, plus, moving down, you put minus. And so, okay, that's fine. So we might say, okay, so that means I've got y is equal to 2 x minus 4 minus 4, and then I've got y equals to 2. Oh, did we say 7 units to the left? Sorry, let me just change that. 7 units to the left. So x plus 7 minus 4. Now let me just go back to my notes here. So if you look at it, this is what's happening. 4 units to the right, it becomes minus 4. When you put 7 units to the left, it actually becomes plus 7. That's the horizontal shift. Now you might be thinking, okay, that's great, but what about a quadratic? So if I'm going to move 4 units to the right for a quadratic and 7 units left, then watch what happens. This is your normal graph. But when we actually do this, because it's actually moving 4 units to the right, we're going to use the same thing as what we did in the linear equation. We're going to replace x with whatever the movement is. So this will become x minus 4 squared plus 3 times x minus 4 minus 2. And if you're doing it 7 units to the left, then this is going to be, sorry, I'm just being lazy. This is going to be x minus 7 squared plus 3 times x, sorry, plus 7. And yeah, x plus 7 minus 2. And if you look at exponential equation, so if you have y is equal to 2 to the power of x, this case it'll become y to the power of 2 to the power of x minus 4. And if you're moving it to the left, it'll become y is equal to 2 to the power of x plus 7. Okay. How was that? Was that helpful? That pretty much covers any kind of horizontal and vertical shift that you guys are going to be doing in the exam. So if you ever see this question, it's like, move this graph up by, what would the equation of this new equation of this graph be if this is moved up by 3 steps, or like 5 to the left and 3 up? What would the new equation be? You follow this kind of ideology, all right? And it works for linear, it works for quadratic, it works for exponential, it works for all 3 of them. So what I'm gonna give you guys now is a simple little couple of questions for you guys to try and do. So we're gonna have y is equal to 3x minus 3, y is equal to x squared plus 4x plus 5, y is equal to 3x minus 2. Okay, and what I'd like you guys to do is this. We are going to do a pretty much like a little grid here. Bear with me. And I'm going to give you guys like 3 questions maybe. So this one, I would like you to move up the graph, move the graph by 5 units. This one, I would like you to move left by 3 units. This one, I would like you to move right by 2 units and down by 4 units. So I will leave this up there for you guys to have a crack at this. So to move it up, have a look here. Who was it? Vishwa. This is basically moving up and down. This is left and right. So have a go. I'm going to give you guys maybe like a couple of minutes. One more thing, guys. By the way, Dashal actually gave me a really good point here. You have to simplify your answers, all right? If you don't simplify your answers, then you are only going to get achieved for it. But if you fully simplify that answer, So I'm talking about like if you have like the quadratic, you probably want to expand it and simplify. If you have the straight line, you want to expand it and simplify. And I'll show you guys in about a couple of minutes. Just need to go get some more water here. Actually need some ice water. But I'll give you guys like 2 to 3 minutes just to have a go at this. And then after that, I'll go through the answer with you guys, all right? Now guys, just for the, I know we've only got about 10 minutes, so we'll probably try and do the expansion of these ones and then we'll call it. So I'll let you guys kind of work through this for another couple of minutes and then I'll go through the answers and then we'll call it for the night, yeah? Yeah, no worries, Dashel. 3x minus 2. Yep, Gabriela, that's correct for the last one. Nishal, I've got a video called what is it? Hang on, just happened here. So I should have a video up there for teaching you how to do exponential from like finding 3 points. Like with given 3 points, you try and work out what the exponential equation is. There's a video for it. If you find it, that pretty much covers all the little variables there. Just look for how to make an exponential equation given 3 points on my channel and you'll find it. Alright guys, I'm gonna go through the answers for these questions here. Hopefully you guys have kind of had a go at it. And like, look, even if you don't get it right expanding, just getting that first part right is really important. And that could still get you an achieved. And then after that, you can kind of just practice some more for expanding, alright? So our first one here, we're moving it up by 5. So we've got 3x minus 3 plus 5, which means that's going to simplify to y equals to 3x plus 2. Next, we're looking at moving left 3. So I'm going to replace the x with x plus 3 minus 3. And I've got y equals to 3x plus 9 minus 3. Which means I'm going to get y is equal to 3x plus 6. Daniel, no, it's a merit skill. But then if they do write like moving it by like p units and q units, then it tends to be an excellence question. And guess what, guys? It doesn't matter if they put p and q in it, because you guys know how to do it with numbers, so you can just replace it with letters. And I'll do a quick example at the end, alright? So the next one is we've got y is equal to 3x minus 2 minus 3 minus 4. So we're going to expand the brackets out, and we're going to get 3x minus 6 minus 3 minus 4. So y is equal to 3x minus 13. Did you guys get that for the last one, or have I made a mistake here? Oh no, we've got someone else with 3x minus 13, so that's fine. Okay, so let's have a look at the quadratic ones. So the quadratic ones, we've got just moving it up. So this is going to be y equals x squared plus 4x plus 5 plus 5. So we're going to get x squared plus 4x plus 10. Fairly straightforward there. Chanui, yes, you do need to simplify if you want to get that full merit grade. Like, I'll show you guys. So this is from last year's exam paper. So they asked this question: find the equation of the new line if the graph shown on page 2 is translated 20 units up and 10 units to the left, simplifying your answer as far as possible. So if you look at the answer itself, they've done the same thing, moving it to the left by 10 units, moving it up by 20 units, and then they have to simplify it to get that merit grade. So correct simplified equation is giving you a merit. So yes, you do have to simplify. Okay, so we are off to the next one, and then the next one is with the quadratic. We've got moving it to the left by 3. So we're going to write this as y is equal to x plus 3 squared plus 4 times x plus 3 plus 5. All right, so as you guys can see, I've replaced all the x's with x plus 3, and at this point I just have to expand the bracket. And again, you know, it might look a bit annoying, but guess what, it does kind of yeah, that's a very good question there, Scribble. You have to think about it like this, right? With the x coordinates, it's always the opposite. Like, for example, you know, when you have like a graph like this, and let's say this is positive 2, right? If that's positive 2, then this point right here is 2, 0. So if you look at the equation, and let's say this is like, this cuts it like, I don't know, minus 6, for example, then the equation is y equals to 2. No, I'm actually giving you a wrong. I want to give you something else. Why would you shift that by 2? Right, so if I have a look at the original, if I put an original equation, would it work? No, wait, let me go back to this, hang on. Sometimes it's easier to help kind of do this with parabolas. So here, if this point is actually 2, right, with the parabola, then, but if you think about it, this equation is actually equal to x minus 2 squared. Now the reason why we always go the opposite for the x versions is because if I put y is equal to 0, I'm going to get 0 is equal to x minus 2, and when I rearrange this, I'm actually going to get x equals to positive 2. So even though the x value, if you think about the parabola actually is shifted to the original parabola. This is what the original parabola is, which is y is equal to x squared. If I shift it 2 units to the right, then I have to put it as minus 2, because otherwise x plus 2 would actually be on the opposite side of it. So this is just something that you need to keep in mind when you're actually shifting on the x-axis. The y-axis not so much. Vertically it doesn't really matter. You always stick to going up plus 5, down minus 5. But horizontal shifting, you've always got to do the opposite. Beats, thank you, appreciate it, man. Like, seriously, pretty cool. Thanks, man, appreciate it. Always get a bit shy when stuff like that happens. But anyway, hopefully that kind of helped Scribble with your question there. But just keep in mind that when you're doing vertical, it's standard, but when it's horizontal, it's it just switches over all the time. Okay, so we've got to expand these brackets here. So I'm going to get x squared plus 6x plus 9 plus 4x plus 12 plus 5. And then simplifying it, I've got 6x, 4x, which makes 10x, 21, and 26. Jack, we'll kind of, I'll show you that as well. Like there's a couple of tricks for that as well. I'll show you that today. I mean, we've actually got a little bit of time. All right. Well, I can't show that to you guys. I won't expand it. What I might do is like the other ones, I'll just leave it as it is, and then I'll show you the little tricks of reflection on the x-axis and y-axis. So what we're going to do, the next one, we've got y is equal to x minus 2 squared plus 4 times x minus 2 plus 5 and minus 4. If we expand it, whatever that comes out, that's what it's going to be. As for the exponentials, we are moving it up by 5, so it's minus 2 plus 5. We are moving it by 3 units to the right, so that's going to become x plus 3 minus 2. And when we're doing a combination, 3x minus 2 minus 4. So those are for the exponentials. So Dens, yes, for the full marks for these questions, you actually want to be expanding fully. Now, since it's the last one, I'll just do that quickly. We got x squared minus 4x plus 4 plus 4x minus 8 plus 5 and minus 4. So 4x and 4x cancels. We've got x squared, 4 minus 4 is 0, plus 5 minus 3. I don't think there's anything like an overall Darshell, like it's just, you've got to know your basics. You've got to know how to get an equation of a if you know how to get an equation of a straight line, parabola, and exponential, you're going to walk away with an achieved or a merit easily, because most of these application questions that they have, they all end up being one of these 3 graphs. So really important that you pick up those basic skills. Now, the last thing I want to do for today, which I know people have been asking, is the reflection. Yeah, the investigation question beats. I will do it next session, because I think we've kind of covered most of it. The investigation one definitely, because it's been coming quite a few times. So we'll definitely do it next session. In here, I'm going to get rid of this. And I'm going to use y equals to, I'm just trying to think. Yeah, let's do some simple ones first. Unfortunately, for this one, I need to move this here. Hold on, so I can see the comments. Not really, Daniel, because let me show you. Give me a second, all right? Is this gonna work? Like, look at this. So dirt, where can I put this? I'm running out of space here. Oh no, we can try this. So if I put in y is equal to x plus 3 squared, no, we're doing the bottom one, x minus 2 squared plus 4 times x minus 2 plus 5 minus 4. And then our final one. So as you can see, both of those graphs, they are literally the same graph. They just overlap each other on top of each other. All right, but we just have to write the simplified version. So this is the version that's like not simplified. And then when we simplify it, we actually end up with the same graph. All right, now, sorry, I missed a few questions, but like, yeah. So as I was saying to Beats and Rani, like, who asked me about the questions on investigations, we will definitely be doing investigations. Chance and data, they'll never do chance and I'll never do chance and data for a very long time. Yeah, we'll go through that one as well for the next time. That's mainly for the quadratic, that one. Yeah, but anyway, the reflection that you guys keep asking about, we can kind of look at this, all right? And this is really easy, by the way, for the reflection. It won't take too long. So I'm gonna put down y is equal to x squared. No, hang on. I want to do x plus 2 squared because it's easier to show you that way. All right, guys. So the first thing is this. We're going to do reflection on the x-axis. All right. So the x-axis, if you want to reflect on the x-axis, all you have to do is just put a minus in front of the entire fraction. Sorry, not fraction, entire formula. So that means I've got the whole formula here. And if I want to reflect this on an x-axis, I just do that. That's pretty much it. That's all you have to do. All right, nothing else. If you want to reflect on the x-axis, you take the whole equation. So let me do another one here. Let's go something like y is equal to x squared plus 4x minus 2 or something like that. Actually, not 4x. Let's go something else. Not 10. I'm trying to think right now. My head is not working. Yeah, there we go. So if I want to reflect this on the x-axis, all I got to do is I'm going to copy this exact same equation, and all I'm going to do is I'm going to put a little minus and a bracket in front of the whole equation. And what that'll do is where's the negative 2 you're talking about? Oh, right, for the exponential. Sorry. Yeah, you guys are right. Yeah, my bad. That's the, you're talking about this, right? Yep. You guys are right. Sorry, that should have been minus 2. Minus 6. Not minus 2. What did I do? Minus 4 and minus 2. Yeah, that's the minus 2 is from the original. Sorry. That's my bad. Is the brackets necessary for the negative? I would say if you want to walk away with an easy reflection. Otherwise, what you'll have to do is you have to take each individual element and you have to change the signs. So you have to go minus x squared, minus 1x, minus 3 changes to plus 3. So notice how, like, by putting the bracket, you're actually doing the whole thing in one shot. So if you want to reflect on the x-axis, where did my pen go? So reflecting on the x-axis, all you're doing is take the entire equation and just put a bracket around it and a minus around it. It's ADAC. Have a look at my level 2 calculus tutorials. And I think this might be in 2020. I did a really good kinematics 1-hour tutorial. It should be there somewhere. Have a look through it, eh? So Muhammad, that's why we kind of do the x-axis. All right, let's have a look at what about y-axis. If you want to do this on y-axis, what must I do? Let's go back this. I forget about this, right? Like, it just, let's get rid of some of these guys. Y-axis, to reflect on the y-axis, all you have to do is this. You just find out wherever there's an x and in front of it, you put a minus. So let's say we have something like this. Y is equal to x squared minus 3x. Would that work? Minus 6x minus 6x minus 8x plus 1. No. 12. Okay, let's do this one here. I'm gonna change the color of that to like orange. So if I want to actually reflect this equation on the y-axis, all I have to do is I actually have to put a minus in front of the x, or multiplied by, and so this would become plus. Why is that not working? What have I messed up? Oh, I know why. That minus has to be in a bracket, that's why. There we go. Because it's getting squared. Yeah, I think I'm doing level 2 on Sunday. Monday we'll do level 1. And then we'll just alternate, guys. And then level 3 is I'm going to do a second double session starting next week, because I'm just going to do excellence questions in the nighttime. So yeah, so with the actually, even you could even do it like this. This might be a better way of doing it, just to make it a bit easier for you guys. So wherever there's an x, you put a negative. So Muhammad, you were asking me before about the brackets for reflecting on the x-axis. For reflecting on the y-axis, find all the x's, put a bracket around it, but then put a negative inside of that x. Let's see if this actually works with an exponential curve, right? So if I look at an exponential curve, let's do something like y is equal to 3 to the power of x plus 2. Okay, let's say I want to reflect this. First off, I want to reflect this on the y-axis. If I want to reflect this on the y-axis, I put negative in front of the whole thing. If I want to reflect on the x-axis, sorry, I did x-axis, sorry, my bad. I just did reflection of the y-axis. Now I'm doing reflection. No, I keep stuffing this up today. I just did reflection on the x-axis. Okay, let's get that right. Now I want to reflect on the y-axis, so I'm going to put a negative in front of that x. So that's pretty much it for reflection, all right? And I know I kind of botched that a little bit, and I apologize about it. But it's just learning where to put the negatives. Now, if for any reason you forget this, you're like, man, I can't remember what the hell he was talking about. Was it negative in front or negative in the back? I can't remember. Doesn't matter, because you have a graphics calculator. Just do a real quick test. Go in there and then put this equation. So put down like, okay, I'm just going to try it out, all right? I'm going to try out. I forgot how to do this. I know you talked about it. 3 to the power of x plus 2. And I'm going to draw it. Shift view window initial. So there's the graph right there. I can see it. Now I need to reflect this on the y-axis. So I know I've got to put negative somewhere. I can't remember which one it is. Well, guess what? You can do both of them. Because I would actually go, okay, let's try this one. Negative bracket 3 to the power of x plus 2. Let's see what happens here. Draw it. I can't really see anything. What's happening? Just zoom out. There you go. That graph right there is actually reflected on the x-axis. So, oh, is it not on screen? Ah, okay, hang on. How about now? Is it not yet? Let's try this. Let's try this. I've just lost everything. Is it on screen now? Sorry guys, I thought you could see it, but anyway, let's try this again. So I was gonna say, like, put down the equation first, and then put down what you think it was, just to test it out. Right? So I've actually put down 3 to the power of x plus 2, and then I put the whole bracket negative, because what that does is that actually shows me both of these graphs. That's actually reflected on the x-axis. Now if I want to reflect it on the y-axis, I would go 3 to the power of wherever there's an x, I'll change it to negative x plus 2. And you can see the third graph there is actually reflected on the y-axis. But look, that's pretty much it for today, guys. Like, I just wanted to kind of focus on some straight lines, and then some kind of things about just reflection and translations, which is always quite handy to have. So with that, I'm gonna kind of log off here because I've got another early morning tomorrow. And as I said to you before, like, practice. It's like, look at the old questions and then see. Hi, Rebecca's mom, how you doing? It's funny because I think I remember once a kid actually mentioned to me that they got into trouble for watching YouTube at 8 p.m. in the night, and their mom didn't believe that they were actually learning. So then she actually got me to say hi to her mom, to actually say like, yeah, this guy's actually doing some maths for a session. So yeah, hi there, Rebecca's mom. So do I play chess? Yes, I do. But anyway, look, before I kind of go off into random chats, couple of questions. If you have a question and I have no clue how to do it, you got to figure out what it is first. Is it linear? Is it quadratic? Is it exponential? Figure that out first, and then we can actually go through after the next steps. All right, so that's usually the case with that. Samuel, yes, I play chess. No worries, guys, you don't have to thank. Like I said, I'm available in Rewa this Saturday, so if you're from South Auckland anywhere and you need some help, pop on down and get some help. Jeez, I'm gonna say hi to everybody. Okay, say hi to people's moms. With the MCAT 2022, I'm not going to be getting the results till January, or not the exam schedule till like March or April. So I'll only be doing it then. ADAC, I don't know who you are, but I don't know where you came from, but I don't know if you came from OJC or MHJC. I did my time 7 years there. Come across, say hi to me across the road. So if we reflect on the y-axis, just make the x negative. Yes, Sukneet. So every x, not just one. Like if you see like x squared, put a bracket for the x and put a negative inside of it. If you see like a 3x, then you'd go 3 times negative x and so on. Yeah, so Rani, we'll do the 2 things that we talked about. We'll do investigation questions and we'll do shape of parabola as well. Karina, that probability tree is like one of my favorites, man. That's the only thing I can teach. It's my favorite of all time with stats. Sending my no worries, Saskia. You're welcome. I didn't realize that, but Jeet Patel, great question. Unfortunately, it's just something you know, as you do more questions, you start picking it up as to what to do and so on. So it's really hard to kind of answer that from straightforward, like which question will be correct answer only and so forth. Vato, Wellington, I got my family down there, man. Like I usually come and visit like every 3 to 4 months. I might actually make a visit to I'm making a visit to Wellington maybe January during when the exam results are out, so I might actually come and have a chat with a few people down in ADAC. I'm going to be down in Manariva Library. Anjay, absolutely. I would say get into the habit of like doing past papers, time yourself, see how long it takes you to do these questions, and then make sure you kind of go back and do those questions again, even if you know how to do it. Yeah, I will be doing another one, Zena. Just need to get through Thursday and Friday, and then I'll start putting it up. Sukneet, that is a shortcut you could do as well. Like you could actually just change the negative of the y, but some people like to keep y positive, like they don't want to leave negative y there. So what they tend to do is like what I do is the trick is then you just do the whole entire equation, bracket, and then -1. I think we might be doing Monday. Lila, I don't recognize that name, unfortunately. Devashni, okay, yeah, I'll actually put some notes down for you guys. So we've got domain, investigation, and changing parabolas, shape of parabolas. So 3 things we'll actually cover next session. I think we'll do it on Monday night, yeah? Yes, Beats, you actually have 3 hours for the exam. Which school are you at, Gabriela? Felix, the level 2 calculus paper's already done, dude. Like, it's all up on the channel, man. So if you go in, like, just go to my main page, youtube.infinity+1, and if you go down to level 2 exams and revisions, there's all your exams, past exam papers. So go through there and find all my previous tutorials and everything. What time will I be at Mandariva Library? I'm going to be there at about 1:30, but I think our room is getting available at 2:15. I'll wear my Infinity+1 hat and t-shirt, so just to let people know where I'm at. Like, I'll probably just hang around, because I've talked to the librarian, and she was like very helpful to do, kind of helping me on Saturday, so looking forward to it. I'm glad I could help you, Jack. Exponentials and parabolas. Yep. So we can do that next time, Ben. Not an issue. Jade, I think you did it, Jade, because you decided to work. You know, I just provided the stuff, but you decided to actually watch the videos and learn, man. Not me. I just make the stuff. So good on you for doing that. Beats, I've seen that happen before. Usually when that happens, what I do is I reset the calculator and then try and see if it works. But sometimes I've discovered that a dimension error is like using the wrong X. That happens. So yeah, I've seen that happen every now and then. Happens. No. Yeah, Gabriella, you still haven't told me what school is it. I mean, like, if it's like down in Wellington, I don't think I can do like both places. Yak, it's a tricky thing, Yak, for me to say that, because if you are planning to do engineering or anything, I would actually say try and depend less on the graphics calculator, because when you get to engineering, like, you know, you don't use a graphics, you don't even use a calculator. They tend to use a lot of fractions and pies and things like that, so you need to be very comfortable with that. No, I've heard of it. I've always wanted to learn how to do Python. I every time I start learning how to do Python, I do like about two sessions, and then I forget about it, and I go back, and then I have to keep restarting again and again. Yeah, I look, like, to be honest, it's like I think the most frustrating thing that I'm finding with life, if I can say, is that there is just so many cool things to learn and just not enough time. And it's like there's so many things I want to learn, but I can't, so I only do what I can. Ben, not necessarily, man. This is a bit more fun, Ben, because I don't have to sit there marking exams or anything like that. Because this one I can just do what I want when I want. I don't have to worry about it. Next TEG, I think we're going to be doing it on Monday, PSV, unless I decide to go a bit hyper and get like a whole can of Red Bull and just do like 2-hour tutorials every night leading up to the exam. Yeah, Wato, I'm curious to know which part of like which school is it? Sunday level 2. Yeah, Sunday level 2, and we'll see how we go. If I have some energy, we will do level 1 later on after that. So it's just 5 days of crazy 2-hour tutorials. It's crazy. Why not? We could pull it off. Samuel, I am shocking, man. Like, I play 5-minute quick games, and I think I dropped to like 400 or something ridiculously low. I was at like 700 at one point. I was pretty happy with that, but geometric reasoning, Pratik, it's a tricky one, because it's like I don't know, it's like a lot of people don't really ask for it. It's like a lot of people doing they do TEG, and I usually just run out of time to do geometric reasoning. Like even the paper, like if you remember, I only released the paper like 2 weeks ago because I just yeah, I don't find that many people do it. Alright guys, enough enough chit chatter. I'm gonna take off because I've got a very early start tomorrow and very long day ahead. By the way, like this is just a crazy idea. I know I'm doing nah, Samuel, I think, look, I'll be honest with you, I've been playing around with the graphics calculator to get the exponential equation one, and I never get it right. I always get it wrong, and I just haven't figured it out. So I wish I could help you with the exponential one. Is that right? Okay, I did not know that. That might actually work out for the level 1s better. Okay, well, I'll have a look at what's on Monday for level 1s, and then we'll play around with it, eh? That's actually not a bad idea, ADAC, because I don't want to be doing a tutorial if I'm competing with physics. I mean, I know a lot of guys that do level 2 algebra doing physics as well. Alright, I'm gonna take off, guys. Have a good one. I might, like I said, if I'll see you guys on Saturday, and I might do need to check with my management at home because she likes to use the TV while and that means I can't stream. So we will sort out something, and if I do, just keep an eye out on the socials, on either on Insta or on you know, or on YouTube. Like if I just jump on live, I'll probably just jump on and just start doing a session on the weekend. So just keep an eye out. All right, have a good one. Keep practicing those exam papers. Don't just watch my videos. Actually do the questions along with me. Try and do those things, and then you should be okay. All right, take care guys, till the next time, have a good one, and I'll see you guys later.